My name is Darryl Ouellette. I am a technology application specialist with Eaton Industries Canada, and I'm here today to talk about the SVX VFD that Eaton sells, and we're going to talk about setting it up from an out-of-the-box situation, so going through a startup wizard, and how to program it and test it for functionality. When you first apply power to it, it's going to come up in a mode called the startup wizard. And as you can see on the screen, it comes up as startup wizard, press enter. And what a startup wizard is the drive asking you a bunch of questions that'll enable you to program the drive effectively and quickly. So if I go ahead and press the enter key, it's going to ask for certain information. Obviously the first one's language, and we're going to leave that English. So you press the enter key. Now we come to a question. It's asking you what application to program it in. And what an application is having the drive customized to what you want it to program in. And what I mean by that is how many parameters it'll take to get this up and operating for your particular function. So we have 7 built-in applications. The first one's basic, second one being standard, third one is local remote, which is it's a special applications for controlling the drive from 2 hardwired locations. Then we have multi-step, and that's for varied speed presets, typically used in the machine industry. Then we have PID control. So with this particular VFD, it can be used as a standalone PID controller. Then we have multi-purpose, which meets pretty much any application, but it's very complex because it has a lot of parameters that you can set. And lastly, we have the pump and fan control. So that's very specific to pumping in the water industry and the fan control, so a lot of the HVAC controls. So for this example, we're going to select standard application. It's very common. It meets a lot of the applications out there. It's designed around hardwired control or field bus control. So I'm going to hit enter on standard application. And the next message we're going to get is you'll notice that the keypad powered down. The drive actually powered itself down, and it's going to power back up with the defaults required for standard application. So the next menu is setup starts, press enter. And now it's going to ask you very particular questions on how you want this to operate. The very first one is minimum frequency, and that is the minimum speed or the minimum frequency the drive will output to the motor. Default is 0. And I'll just leave it there. Typically it wouldn't stay at 0. It'd be 5, 10, depending on what your process desired, but I'm going to leave it at 0. Maximum frequency, 60 hertz. It's quite common in North America. We're going to leave that default. Then we come to the acceleration time, and that's the time it takes to ramp the drive from 0 frequency up to maximum frequency being 60. Our default is 3 seconds. A lot of applications and processes, that's a little quick, so you may want to change that. So I'll just show you how to quickly change it with the keys. So you just hold the up arrow. If I want to do a 10-second ramp, you can either hold the keys. The longer you hold the keys, the faster it ramps. Or you can simply hit the side arrow key and you can do individual digits. So I'll put it to like 10 seconds as an example. And when you're happy with your acceleration time, just hit the enter key and it moves you on to the next question, being the deceleration time. Most applications, you want to keep your accel and decel time the same. So I'm going to change that to 10 seconds as well. So I'm going to move it over. So I'm doing the quick key method rather than using the up and down arrows. I'm going to hit enter. Then it asks what is the current limit. The current limit is a parameter that limits the amount of current the drive will output to the motor. In a variable torque situation, which are typically fans and pumps, you would want to put in your motor nameplate times 10%, so 1.1 times. Calculate that, put the value in. If you're in a constant torque application, like any piston pumps, conveyors, you would go 1.5 times, so 150%. But for demonstration purposes, we're just going to leave it default, and I'll hit enter. Then it talks about motor nameplate voltage. Now it's very important for a drive to work effectively and properly to have the proper motor nameplate voltage. I'm going to leave a lot of this default. In this case, I'm just working on demo units, so I'm going to leave it 230 volts, but if you wanted 460, you would certainly edit that, put 460 or 575, but the key is it has to match the nameplate, what's stamped on the motor. So I'm going to hit enter, Motor nameplate frequency, 60 hertz. I'm going to leave that default, press enter. Motor nameplate speed. This is important when you're doing any speed control. This particular drive can be either frequency control or speed control. So this particular parameter is used for calculating the motor RPM. So very important for speed control. So that matches nameplate. I'll just hit enter. And then the motor nameplate current. This has to be exact for your motor protection. So this is a device, the drive, that will protect your motor. It has a built-in algorithm. It's an I squared T. So if this motor nameplate information is wrong, then your protection of the motor will be incorrect. If you're utilizing the service factor motor, which I don't recommend for VFDs, you would adjust this as well to match the service factor. So I'm going to leave that default, and I'm going to hit enter. Then it comes to the power factor. And the power factor sometimes gets confused with motor efficiency. That's not the case. If the motor power factor is not stamped on the keypad or available from the motor manufacturer, I would leave this default at 0.85. Then we come to a parameter called local control place. This particular drive has two control places, and you can see it, I don't know if you can see it in the screen, but we have a little local remote button here. It has two modes of operation. It's got local and remote. And you can also see there's little LEDs here. It might be hard to see, but we have a local LED and a remote LED. So how this drive is programmed is at the push of the button, we can pick and choose where local is going to be and where remote's going to be. And a control place is a start-stop signal. And so that's where the commands are coming from for starting and stopping. By default, the local control place out of the box is the keypad. That means my start and stop is going to come from these buttons, start, stop. So that's the default. So I'm going to hit enter on that, and we could pick and choose. If we wanted to change that, I could certainly, I could go field bus, I can go I/O terminal, and we'll talk about these different modes in a little bit here for remote. So I'm going to leave it default. I'm going to go keypad. Then it's asking me, when I hit this button, and it's going to look at the remote location, where am I going to get my start-stop from? So the default is an I/O terminal, and when we pan back it a little bit, we're going to see some switches over off to the side. And I'll show you how we're going to control it with the I/O terminal. But you notice we still have the same selections. We could also pick keypad or field bus. And field bus is if you're using a communication protocol like Modbus, DeviceNet, Profibus, and so on, any of the industrial protocols. So for this demo, I'm just going to leave it on I/O terminal. That's the default. And probably 90% of the time, a lot of people are still controlling it from I/O terminal. So we're starting and stopping through a digital input, so a relay or a switch. So I'm going to leave that default. Then we're asked the questions, when I'm in local, so when this LED is illuminated, where is my speed reference going to come from? So the drive has to actually get a reference for it to output a frequency. The default is the keypad. That would mean if I was pointing here, it would look to the keypad for the speed reference, and we can adjust it with these up and down arrows. But right now it's just a pointer to ask where is that information coming from. So I'm going to leave that default. I'm going to press enter. Then we have remote reference. So now we know we're starting and stopping from an external I/O terminals, but where is that speed reference coming from? So these analogs, AI stands for analog in. We have a couple analog ins built right onto the board. So we have analog input 1 and analog input 2, and it gets hardwired to the drive through the interface board. But we can pick and choose a number of different places. So as you can see, we can make the remote reference field bus. We could also point back to the keypad, or we could use one of the onboards. So I'm just going to use analog input 1 since it's the default. And I'm going to hit enter. And then we have another parameter called input phase supervision. These are designed as 3-phase input drives. So the drive can protect itself if in the event that you lose a phase. The default is to fault or coast. For my particular demo, I have a drive that is basically single phase in to monitor. So I'm going to choose no action on that because when I'm done the startup wizard, it's going to come up and say input phase fault. So I'm going to set it to no action. That way I can reset it and continue on with the demo. But in most cases, it would stay at the fault. It would stay at this particular setting here, fault coast. So what fault means is if you lose a phase, input phase, it's going to fault. And the VFD is going to coast, the motor is going to coast to a stop. Okay, so basically disconnects the power. So in my case here on my demo, I'm just going to hit no action. I'm going to hit enter. And that's all the questions for the startup wizard. Then it asks you, do you want to repeat the setup? Because if you made a mistake, you could always go backwards and repeat through. I'm going to say repeat setup no. And it says setup done, and I'm going to hit enter. Okay, you notice that last parameter I set, input phase fault, the drive had recognized when I powered it up that the input phase was missing because this is a demo unit being fed single phase input. So I'm just going to reset that to continue on. So once all said and done, your drive is now programmed to run from the local mode. You see how the local LED illuminated? And I don't know if you can see it on the screen, but it also tells you where the control is coming from. It says keypad there, right beside the top and the ready. So you can see at the very, it says stop, ready, and right below it, it has keypad. So it's actually telling you local control is coming from the keypad. So now that means I can actually start it and stop it from here. So if I wanted to start it, I can hit start. And the drive starts. You notice how the turn to a run state, but it's not running at any particular frequency. But if you remember back to the parameters, the speed reference is coming from the keypad. And the quick way to change the set point is with these up and down arrows. So we got the plus up and we got the minus down arrow. So if I want to give it some frequency reference, I hold it up. It says keypad frequency, keypad reference. And now the VFD is running and is outputting frequency. So that's operating the drive in the local mode, which is keypad. So I can start and stop from the keypad. The drive stopped, and I can start it, and it'll ramp up. So one nice feature with this drive is we did add this local remote button. So now if I wanted to control it from the I/O terminals, in this case, this particular demo, we have wired all the hardwired signals into the drive. We have a bunch of digital inputs, and we have some analog dials here for speed reference. If I wanted to switch to remote mode, I hit this key here called local remote, and it asks you, select remote, press enter. I'm going to hit enter. And a couple things happened here. The LED for local changed over to remote. So now if we go to our screen at the top, below the stop, we can see I/O terminal on the keypad. So that's telling you the start and stop is now coming from the I/O terminal. So if we pan over here to this switch, by default, the very first digital input is a run signal. So if I turn that switch on, you notice the drive goes into a run state. And if you remember from the startup wizard, our analog input 1, I can control the speed with this voltage input potentiometer. Okay, so you've programmed the drive into two different modes, keypad and I/O terminal. And we can also stop the drive. Okay, so that's the startup wizard on taking a drive out of the box and getting it programmed. Now I just want to point out a couple other things. It's from a maintenance standpoint. For troubleshooting, a lot of times you're not sure if your signals are getting there or not. So we can go into different modes in this drive. So we want to get into the programming portion of it. So a couple ways to do it. So if I hit the left key, I can get into programming, and I can hit the enter and drill in that way. But another simple way is if you forget how to get into programming, if you hold the enter key down for 5 seconds or a couple seconds, it puts you right into the programming mode. So in there we have a menu structure. We start off with parameters. We have some keypad control parameters, active faults. Active faults being the faults that are active on the drive. Fault history are faults that have occurred and have been reset. And if we were to go in there, anytime you see the right arrow means you can drill farther down into the menu. If I hit that right arrow, you'll notice we're showing that input phase fault we had when we finished the startup wizard. Okay. If we want to reset the fault history, that's very simple as well, as we can also hold the enter key down on that, and it resets the fault history. Then we can keep going on. We have a system menu parameters, which gets into the background of the drive. Expander board menu is inside this drive. We have option slots in here. The drive comes with 2 boards, and that's to interface all these digitals. So we have 2 option A9 card and an option A2 card. So it comes with 2 cards built in. And then we have 3 extra slots for other option cards. So if we go around to the monitor menu, there's some neat features in here. such that we can see what frequency reference it is. And because we're still an I/O terminal, we're looking at this potentiometer for frequency reference, so we can see what speed the drive is supposed to run at if it was running. If I was to go to the local, which is the keypad, you'll see what the keypad reference is, and you see how this potentiometer no longer has effect. So now it's looking at the keypad for reference. So I'm just going to go back to remote for now, and I'll keep going through some of the monitoring parameters. So it talks a lot about when the drive is running, but I want to show you a few here that will help troubleshoot any hardwired situation. So in this particular monitoring menu, we can actually see what signals are coming into the drive from the I/O boards that are in this. And since we're on remote analog input 1, we can see by turning the potentiometer, I can measure my 0 to 10 volts that comes in on analog input 1. The analogs on this drive are configurable to voltage or current. Voltage being 0 to 10 and current being 0 to 20 milliamps or 4 to 20 milliamps. By default, analog input 1 is voltage. So I'm turning a dial here on my demo unit so you can see it. So that's a troubleshooting technique to find out if a signal is actually making it to the drive. Then we have our second analog input, which is the current, and I have another dial here. You can verify that your signal is actually making it to the drive. Okay, as well as you can look at your digital inputs. Okay, in this case we have 6 digital inputs. On this screen we have the first 3, and this screen we have the next 3. So if I was to flick on digital input 1, which is our start signal, you can see how the input went on and the drive went to a run state. So I'll turn it off, the drive stops. So all these digital inputs, they have assignments on what they're supposed to do and how they interact with the drive, but you can see from a maintenance standpoint, you can go ahead and turn signals on and off and actually see if they meet the drive. That last switch there caused an external fault, so I'm just going to reset that. Okay, and then we have our other switches. So we have 6 digital inputs, and just by looking at this screen you can tell if there's a signal there or not. So it almost makes it as simple as not having to have a multimeter to troubleshoot this drive. We also have 3 outputs on the option cards. We have a digital output, and it's programmed to a ready signal. Because the drive is ready, that digital output is on. Then we have relay out 1 and relay out 2. By default, this is a run, and this is a fault. So if I was to make it run, you can see how the relay output turned on. Okay, so we know it's changed state. And then if there is a fault, you can see how I turned that. I caused a fault. You can see how that relay turned to a fault mode. I'll turn the fault off and I'll reset it. Okay, so we're back to the drive ready state. We also have an analog out. We can read what signal we're sending out to it. So if you're monitoring anything through milliamps, we can see what output's going on. The default is output frequency, and it is milliamps, and you can see when the drive runs, we can see the actual milliamp output. Okay, so that was a quick overview of taking an Eaton SVX drive out of the box, brand new, going through the StartUp wizard to have it programmed for your application, and some simple little maintenance tips on troubleshooting just to help you if there's any problems along the way.